Hi friends, in this video we are going to learn about Rolle's theorem. The statement of the Rolle's theorem says if the function is continuous on closed interval AB from here to here, that is function is continuous on the closed interval AB and differentiable on the open interval AB except this end point A and B, your function is differentiable on this open interval AB, then there exists one point C such that f dash of C equal to 0. F dash of C equal to 0 means slope of the tangent at this point is 0. The slope of this tangent at this point is 0 means slope of this tangent is same as the slope of this x-axis, because slope of the x-axis is 0. This means that this tangent is parallel to x-axis. So here the geometrical interpretation of the Rolle's theorem says the slope of the tangent which is parallel to x-axis and the slope of the tangent is same as slope of the x-axis which is 0 and the slope of the x-axis is 0. So here Rolle's theorem says that if function is, first condition, continuous on closed interval AB. So here if the function is continuous on the closed interval AB, and second condition is differentiable on open interval A to B. And so here function is continuous on the closed interval AB, second is function is differentiable on open interval AB, means f dash of x exists for all x belongs to the open interval A comma B. And third condition is here f of A equal to f of B. Function value at endpoint A is same as functional value at endpoint B. So you can observe one thing, this is A and the image of A under function A is f of A, and this is B, image of B under function f is f of B. So here this is f of A and this is f of B. You can observe one thing, f of A is same as f of B. That is the third condition of the Rolle's theorem. Then there exists C belongs to the open interval AB such that f dash of C equal to 0. That is the statement of the Rolle's theorem. The statement of the Rolle's theorem says if the function is continuous on the closed interval AB, means function is continuous for all the point x belongs to the closed interval AB and which is differentiable on open interval AB, and the function value at A is same as function value at B, then there exists C belongs to this open interval AB such that f dash of C equal to 0. Now so here for example if you have one function, how to check whether the given function satisfy the condition of the Rolle's theorem or not. Here working rule, here I will write working rule for verification of Rolle's theorem. So here what is the working rule for the verification of the Rolle's theorem? When we say that the given function satisfy all the condition of the Rolle's theorem or not. So for example the first working rule is, so like in the statement, check function is continuous on closed interval A to B. So here first working rule, we have to check whether the given function is continuous on the closed interval A, B or not. So here this is interval A to B. We have to check whether the given function is continuous on closed interval A, B or not. Here second working rule, check function is differentiable on open interval AB. So after checking the continuity of the function from closed interval AB, next condition, check whether the given function is differentiable on the open interval AB or not. That is f dash of x, that is f dash of x exists for all x belongs to the open interval AB. That is my second working rule. That is my second working rule. Now third condition, here check f of A equal to f of B. So after that check the function value at A in point A is same as the functional value at endpoint B or not. So here fourth condition, find C find C by using f dash of C equal to 0. If C belongs to the open interval AB, then we say Rolle's theorem verified. So here if C is not belongs to the open interval AB, then we have to say the function is not applicable for the verification of the Rolle's theorem. Now here I have an example. Let's say f of x equal to x square. Now here this is my example, f of x equal to x square. Now check whether this function satisfy all the condition of Rolle's theorem or not in the given interval -1 to 1. So here answer is, now the first condition, check the given function is continuous on the closed interval AB. So here you know f of x equal to x square is continuous on the closed interval AB. Here given f of x equal to x square defined on closed interval -1 to 1. So here first condition, f of x equal to x square is continuous on closed interval -1 to 1. So here since this is the polynomial, f of x equal to x square is a polynomial which is continuous on R and therefore which is continuous on the closed interval -1 to 1 as a polynomial function in x. So here f of x equal to x square is continuous on closed interval -1 to 1 as a polynomial function in x. Now second working rule, check whether the function is differentiable on the open interval AB or not. Therefore now find the derivative of f of x, that is f dash of x equal to 2 times x exists for all x belongs to -1 to 1. Therefore here f of x is differentiable on open interval -1 to 1. Now here second working rule is also satisfied by the given function f of x equal to x square. Now check the third condition. Third condition is f of a equal to f of b. Here a is -1 and b is 1. Therefore f of -1 which is equal to -1 square which is equal to 1 and f of 1 which is equal to 1 square which is equal to 1. Therefore f of -1 equal to f of 1. Now here three condition of the Rolle's theorem is satisfied by the given function f of x equal to x square. Now we have to find the value of c by using this f dash of c equal to 0. If c belongs to this open interval -1 to 1, then we say that the given function satisfy the condition of the Rolle's theorem. Now here fourth condition, here find c by using f dash of c equal to 0. Now f dash of c equal to 0 means f dash of x equal to 2x. Therefore f dash of c equal to 0. This implies that here f dash of c equal to 0 means that is 2c equal to 0. This implies that c equal to 0 and that belongs to the open interval -1 to 1. You can check here 0 belongs to this -1 to 1. Therefore given function satisfy all condition of Rolle's theorem. All condition of the Rolle's theorem. So here Rolle's theorem says, here I will explain one more times. If the function is continuous on the closed interval AB and which is differentiable on the open interval AB, and check whether the given functional value at endpoint A is same as endpoint B, then there exists C belongs to this open interval AB such that f dash of C equal to 0. F dash of C equal to 0 means slope of the tangent at this point is 0, means this tangent is parallel to your x axis. So this is your x axis and this is your y axis. Now how to check? Working rule for the verification of the Rolle's theorem. For example, if you have the function, when we say that the given function satisfies the condition of the Rolle's theorem or not, the working rule, check whether the given function is continuous on the closed interval AB or not, and check whether the given function is differentiable on the open interval or AB or not. After that, check functional value at A, endpoint A is same as the functional value at endpoint B. If f of A equal to f of B, then find the value of C by using f dash of C equal to 0. If C belongs to this open interval AB, then we can say the Rolle's theorem is verified. If C is not belongs to the open interval AB, then we can say Rolle's theorem is not applicable for this so and so example. So here in the example, f of x equal to x square is in interval minus 1 to 1. So here f of x equal to x square is defined on the closed interval minus 1 to 1. F of x equal to x square is continuous as a polynomial in x. So here first condition is verified. F of x is differentiable, that is f dash of x equal to 2x exists for all x belongs to this open interval AB. So this means that function is differentiable on the open interval AB, and functional value at minus 1 is 1, function value at 1 is 1. So f of minus 1 is same as f of 1. Third condition is also satisfied. Then find the value of C by using f dash of C equal to 0. Here f dash of C equal to 0 implies that 2C equal to 0, that is f dash of x equal to 2x. So f dash of C equal to 0, 2C equal to 0, this implies that C equal to 0, that belongs to the open interval minus 1 to 1. So here this given function satisfies all the condition of Rolle's theorem. Hence Rolle's theorem is verified. Therefore we can write here, hence the given function verify the Rolle's theorem. Thank you.